So our next lesson is adding and subtracting square roots. So my upper left-hand corner here, we have the example problem from our opener. It's showing us what like terms are. This is going to be example number 1 that you're going to want to write on your paper. I will tell you this, if you write large or you write big like I do, I would try to write a little bit smaller, okay? So if you tend to write a little bit bigger, try to write a little bit smaller on your example problems today. So this first example here, the square roots have already been simplified. So my first example, I don't need to worry about simplifying my square roots because it's already done for me. When you're adding and subtracting square roots, you can only add or subtract square roots that have like terms or that are in common. So how do you think we identify what square roots are alike? Deontay?
The first and then the last, the 5 square. The first and then the last.
Okay, so he did Deontay went ahead and identified what our like terms were here. The 2 square root 2 and the 5 square root 2. What did you use to identify that they were like terms? Do you use the coefficient, which is the outside number, or the radicand, which is the inside number? The radicand. So when you're adding and subtracting square roots, you can only combine like terms. When I say like terms, you're going to compare it to the radicands. They have to have the same radicand. Your radicand is your inside number. So if you're looking here, the first term and the third term are going to be like terms. Now, the second thing you need to do is only combine the coefficient. The radicands stay the same. You're not going to combine, you're not going to add or simplify the radicands. You're only going to simplify the coefficients. So my coefficient is going to be 2 plus 5. So what's 2 plus 5?
7.
So I'm going to put my equal. If my square root or my radicand stays the same, it's going to be 7 square root 2. And then do I have another number up here or another term with the square root of 3?
No.
No, so I'm just going to bring that down. And that's going to be my final answer. Another thing you need to remember, when you're simplifying or you're adding or subtracting square roots, you're going to put them in order from least to greatest. So you're going to put your radicand, the smallest radicand will go first, then this next radicand, okay? So there's a lot of things that you're going to have to remember. Okay, let's take a look at example number 2.
Put a box.
So example number 2 is the square root of 27 plus the square root of 18. Now, in this example problem, my square roots are not in simplest form. So this is where last week's lesson comes into play. So before we can add these 2 square roots together, we have to put them in simplest form. So what that means we're going to do is simplify the square root of 27 and simplify the square root of 18. Then we're going to have to rewrite them. So the way that we're going to do this is start with the square root of 27. What 2 factors can I use to multiply together to get 27? Okay. For 9? Okay. Before I rewrite that, I am then going to come over and I'm going to find my factors of 18. So what 2 numbers can I use to multiply together to get 18? Rihanna?
2 and 9.
So we're going to do 2 and 9. 2 is prime. What about for my 9?
3.
Use yesterday's date still, Mr. McFarland, because we're going to do 2 openers tomorrow. Okay, so that's step 1. That's step 1. The second thing you're going to come down, I'm going to write right underneath it, I'm going to put my equal sign, and I'm going to put my square root of 7 prime factors under my square root sign. So what are my factors for 27? Times 3 times 3. What operation sign do I bring down? Addition. And then I'm going to put my square root. And then I'm going to put my factors of 18 under my square root sign right below it. So it's going to be 2 times 3 times 3. from here, I'm then going to circle my factor pairs. So let's look at my first square root here. What are my factor pairs? 3's. So I'm going to circle my pair of 3's. And then my factor pair on this one? 3's. I'm going to come down again. I'm going to put my equal sign, and then I'm going to go ahead and do basically kind of my step 4 here. So my factor pair becomes a single number in the coefficient. So my 3 is going to cancel. It's going to come a single number on the outside. But what am I left with on the inside yet? Just a single 3. So it's going to be 3 square root 3. Again, I bring down my addition sign. What happens with this factor pair here? And becomes a single number in the, and then what am I left with as the radicand? The 2. Now you're going to look. Quit jumping ahead of me. Now you're going to look. Do you have common terms? Do you have like terms? Are your radicands the same?
No.
No. However, I want your final answer written least to greatest based on your radicand. So what happens here? Which radicand's smaller, 3 or 2? So what are we going to do with our answer? Yeah, just switch them. So it's going to be 3 square root 2 plus 3 square root 3. And that will be your final answer. Y'all have it down? Okay, let's take a look at our next example. Okay, so now we have 4 terms. When I say terms, it means 4 parts of the problem, okay? So we have the square root of 8 plus the square root of 100 minus the square root of 32 minus the square root of 16. What am I going to do first? Before I can start solving this, what do I need to do to each of these square roots? Factor them, because I need to simplify them. I need to put them in simplest form. So go ahead and take a minute to factor out each of these square roots. Again, if you write big like me, try to write a little bit smaller. Okay, so looking at these numbers here, before we move any further, what can you tell me about 2 of these square roots that are up here? Anybody notice anything about 2 of these square roots, Darius? Yeah, 2 of them could have been perfect squares. So you could really rewrite 2 of these square roots differently than just factoring them. So what are my 2 perfect squares here?
8.
No? What are my 2 perfect squares here? 16 and 100. Okay, so now that we have them factored, we're going to drop down. And we're going to rewrite them all. So I'm going to write my equal sign, my square root sign. What are my factors for my first square root? Good. What operation sign do I bring down? Plus. Now I'm going to bring down my next square root. What's my square root here? Okay. What's my operation sign that I bring down? Subtraction. Square root. What do I put under this square root sign? So I have 5 2's, right? What operation sign do I bring down now? The subtraction sign. And what do I put for my square root of 16? What are my prime factors? Good. From here, you're going to go through and you're going to circle your factor pairs. So we have a factor pair. So we're going to go through, we're going to circle our factor pairs. After we circle our factor pairs, we're going to rewrite each simplified square root. So let's look at this. So I'm going to put my equal sign for my square root of 8. Simplified, it's going to be what? 2 square root. Okay. Bring down my addition sign. Okay. For my next one here, what happens with both of these numbers? They both cancel with the square root sign. So if they both cancel with the square root sign, am I going to have a square root left? Okay, you can then just multiply them together. So what's 2 times 5? 10. What operation sign do I bring down? Minus. Okay. Now we're going to simplify the square root of 32. How many 2's am I moving to the outside as a single number? 2. So you can write 2 times 2 and then simplify it later, or you can just simplify it from the get-go. Since you're moving 2 to the outside, what's 2 times 2? 4. What am I left as the inside number? So 4 square root 2. What operation sign do I bring down? Minus. And now what's going to happen with this last square root? They're both going to cancel with the square root sign and move to the outside. So what's 2 times 2? 4. That's an ugly 4. Okay. We're not quite finished yet. So now we need to simplify. We need to solve. So here we need to identify what our like terms are. So the first thing, so when you have just the number without the square root, those numbers will go first. Because basically it doesn't have a radicand, right? So if it doesn't have a radicand, then it's going to be smaller than the square root. Does that make sense? Because basically 10 square root is 0. Well, which comes first, 0 or 2? 0. So we're going to first just deal with our terms without the radicand or without the square root. So what are the like terms that do not have a square root? What kind of 10 is that? And what kind of 4 is it? Okay, so then what are my other 2 like terms here? 2 square root 2 and what kind of 4 is that? Okay, so we're going to first combine my 10 minus 4. So what's 10 minus 4? So we're doing positive 10 minus 4. What's 10 minus 4? 6. Then we're going to combine 2 square root 2 minus 4 square root 2. Now, my radicands stay the same, right? So my radicand's going to stay the same as a square root 2. So then you're basically just taking your coefficient. What's 2 minus 4? Use your calculator. What's 2 minus 4? Say it again. It's a negative 2. That's your answer. So 6 minus 2 square root 2.
We do the numbers first and then the square root numbers?
Okay, so that's example number 3. You have it down? You have it? All right, let's take a look at example number 4. Example number 4, we have the square root of 12 plus the square root of 27. So go ahead and start factoring out the square root of 12 and the square root of 27. And I am too. Okay. After I factor out each square root, I'm going to come down and I'm going to write them in simplest form. So in order to start writing them in simplest form, I'm going to put my square root. What's going to go under my first square root, Isaiah?
2 times 2 times 3.
Okay. What operation sign do I bring down, Isaiah?
The plus.
And then what goes under my second square root sign?
You see it talking to me?
Go ahead.
3 times 3 times 3.
Hey, ladies and gentlemen, the extra comments need to stop. Okay, so now we have equals the square root of 2 times 2 times 3 plus the square root of 3 times 3 times 3. Brendan, from here, what do I do? Okay. Kelsey, from here, what do I do?
You put 2.
So my factor pairs cancel, become a single coefficient on the outside. So basically you're simplifying. So I go ahead. 2.
And then square root sign and 3
Okay, keep going.
plus, and then you cancel off those 3 square root sign 3.
Good. Beyonce, from here, what do I do?
No.
You look and see, are your radicans the same? Are your inside numbers the same here?
Yeah.
Yes. If your radicans, you add the outside. You add your coefficients.
5.
So 5. Your radican then stays the same. 5 square root 3. Is it? Okay, I just didn't hear you. Sorry. Nice job. And now we're going to write the note part out. So I highly recommend that you write each and every single word that's going to come up on the screen next, because you can use these on your quiz and your triad test. All right, so let's look at the first step. So adding and subtracting square roots. The first thing you're going to do is simplify all square roots completely. If you forget how to do step 1, then you'll have to refer to your simplifying square root notes. Step 2, you're going to add like terms. Basically, terms with the same radican. Yes. Put what I have in parentheses on your paper as well. Then the final step, using the radicans, write the terms in increasing order. Basically, smallest to biggest. Yes, write what I have in parentheses down again. I'll give you a couple of minutes to get this down. Have those notes written down. We're going to look at some more example problems. So go ahead and, turn your note sheet over. No more example problems. Oh, you're done. Do you guys feel like you have this?
Mm-hmm.
Are you sure you have this?
No worksheet though.